All right, we're back. This is Techmath1. We're looking at chapter 12. So chapter 12 is dealing with oblique triangles. Those are non-right triangles. And so we still know some stuff even when it's not a right triangle. We can use the law of cosines, we can use the law of sines to find missing sides and missing angles. Let me show you how to do that. So first, when you know two sides of two angles of a triangle, you actually know all three sides because you know they always have to add up to 180 degrees. And so if you have 53 here and 42 there, that's, add those together, 95 total. And so you subtract that from 180 and you get 85 degrees, right? Same with this. If they give you 110 and 45, you add those together, take it away from 180, so 155 away from 180, right? We'd have to borrow 7 and 10 and 5 and 2, so 25 degrees. So if you have two angles of a triangle given, you actually have all three angles. All right. Okay, so applies to oblique, but the Pythagoreans. So Pythagorean's theorem does not apply to oblique triangles. Any triangle which does not contain a right angle is an oblique triangle. So we have right triangles and we have oblique triangles. So that was 12.1. Let's take a look at 12.2. Right triangle methods and oblique triangles. So I want to jump to number 10. And so what we have there is when drawing an oblique, so what do they want me to find? EF. Okay. So here, they give you this triangle. They tell you this angle is 50 degrees. They tell you this angle is 45 degrees. And then they drop an altitude. So from that point, they drop an altitude, which is 90 degrees on either side of it. And so what they're doing here is they're kind of splitting it into two different right triangles because they have the altitude on there. So we can find, let's see, they want us to find D, F, this is F, this is E, and this is D, and this is C. And so they said, okay, use your right triangle trig, because we basically engineered a right triangle out of an oblique triangle. We dropped an altitude in at 90 degrees, and so we can look at this triangle as kind of separate from that triangle. So it says find length EF. So if we wanted to find that length and we wanted to use this angle, that would be oh wait, did they give us, oh, they gave us one more piece of information. I was going to say we still need one more piece of information. They gave us this side, 8.47 inches. All right, so we know that's 8.47. So opposite and hypotenuse is sine, right? SOHCAHTOA. And so opposite and hypotenuse. So the sine of 50 degrees is equal to, we'll just call that little c over 8.47. And so the missing side, the EF, is going to be 8.47 times the sine of 50 degrees. Okay, and so you pop that in your calculator. It is 6.49. Then they say, okay, well now find the length DE. Well now, if we know this is 6.49, and we know this is 45 degrees, and they want us to find this, we can do that. So let's do that. The sine of 45 degrees opposite over hypotenuse. We're going to be finding the hypotenuse. We'll call the missing side h. So 6.49 over h. And now we cross multiply and solve. Remember how to do that. That's over 1. So that times that. That's h. Sine 45 degrees equals 6.49. And if you looked at other lectures, I told you you can just swap those out, the h and the sine 45, because that's the end result anyway. When you cross multiply and solve, 6.49 divided by the sine of 45 degrees. And so you do that, click that in your calculator, you get 9.18. And so that's length DE is 9.18. All right. Okay, so let's take a look at the law of sines. We'll do a law of sines problem. So the law of sines basically just says the side opposite the sine of the angle is equal to the side opposite the sine of an angle. So that's true on any problem and so yeah, I guess we'll just look at 12.3. It's not really a problem, they're just basically telling you the law of sines, and it doesn't matter which one's on top or which one's on bottom. So look, you can say it like this: A over the sine of angle A is equal to B over the sine of angle B equal to C over the sine of angle C. Now, they don't want you to do it with 3, okay? You just, any 2, that is always true. So that's true statement. They're always proportional. The side opposite over the sine of the angle is always equal to the side opposite over the sine of that angle. And so this is, we'll make a triangle here, call it ABC. So this is little c, this is little b, this is little a. And basically, if you take this side over the sine of this angle, it's equal to this side over the sine of this angle. Or this side or the sine of that angle is equal to this side, this side over the sine of that angle. It doesn't matter which one, you know. You can do A and B, B and C, A and C. Any of them, that's fine. Oh wait, C. So that's always true. And it doesn't even matter which way you set up your proportion, because you can flip those around too. You can put the sine A on top over A, whatever you want. It's the same. So I could put it like this if I wanted. It's just then I have to have the sine B on top over B. Because remember, when we cross multiply and solve, this would be A sine B, B sine A. That's what they would equal. Same thing. A sine B, B sine A. So it really doesn't matter who's in the numerator or denominator, just as long as the one you set it equal to is the same way. All right? Okay, let's do some problems. 12.4. So use the law of sines, and I wanted us to do which one did I do for the law of sines? Oh, you know what? I kind of skipped 12.4 because they didn't really have anything to set up here. You know what? Let's do 20. We'll do number 20. How about? So there's one in 12.4. So 12.4, we've got this triangle given. 67 degrees, 38 degrees, 18.5. All right, and this is P, and this is Q, and this is M. And so they want me to find MP. So they want me to find, we'll call MP little baby q, okay? Q. So how would I go about doing that? Well, I would set it up. I would say 18.5 over the sine of 67 degrees, that over that, is equal to Q, which I don't know, over the sine of 38 degrees. And now you don't quite have to cross multiply and solve. I mean, you can, I guess. Well, to keep it consistent, we will. But you could, I'll just show you a shortcut out of cross multiplying. 8 degrees, and then divide both sides by sine 67, right? So instead of doing that in like 2 steps, you're going to take 18.5 times the sine of 38 and then divide it by the sine of 67. You could have just multiplied both sides by sine 38. So it's on the top here, it cancels, it's on the top there, and you get that, you know, without cross multiplying and solving. But either way is fine. Now, when you key this in your calculator, you can write 18.5. You could do times sign or not, it doesn't matter. You hit sign, it throws that up. Now you do 38, make sure you're in degrees, and you have to remember this end parenthesis. Everybody forgets that. And then divided by sine 67. And it doesn't matter if you put the last one on that 67, but this one does matter that you cut it so it takes the sine of 38. Otherwise, it takes the sine of 38 divided by the sine of 67, and then takes the sine of that. It does the 38 times sine 67 and the sine of that, and you get the wrong answer. So do not forget that second parenthesis. It puts in automatically the first one, but you got to remember that second one. All right, so double check yourself, key that in, you should get 12.4. And here, we'll do it in the calculator without that parenthesis. And if you have that, then you know you forgot that. 18.5 sine 38, and I'm not doing the end parenthesis, divided by sine 67, and then I hit enter. If you got 12.2, you forgot that end parenthesis. So entry, and we'll go back up there, and insert, and that, and there's the 12.37, 12.4 when we round. Okay, so if you got 12.2, you did it wrong. You forgot the parenthesis on the after the 38. All right. Okay, let's look at 12.5, using the law of sines to find missing angles. So it's the same thing. Let's do 33. That was 20. Let's do 33. That's on 12.5. So they got a triangle. This is 7. This is 11. This is 38 degrees. And I think they're going to want us to find which proportion below would you use to solve for angle B. Oh, okay. And then they give you 2 choices. Well, let's find it. Let's actually find angle B also here. So this is angle B. So we would say the 11 over the sine of angle B is equal to 7 over the sine of 38 degrees. So that one, they set it up the other way around. On B, they have sine B over 11 equals sine 38 over 7. That's fine, same thing. So now let's cross multiply and solve, but this is going to be a little trickier than that. So we got 7 times sine B equals 11 times sine 38 degrees, except then we divide it by 7. So we have the sine B is equal to this. Well, this we can figure out on our calculator. It's probably not going to be pretty. Let's go 11 sine 38 and parenthesis divided by 7. So that's this decimal, 0.9674668. But I don't want to take the sine of that, right? The sine of some angle is equal to that. So I want to figure out what angle goes with this decimal. So that means B is equal to the arc sine. Remember the little sign with the -1 on it. 0.9674668. And so to key that in, let me show you. So I've got the number in my calculator already, okay, the point, and I want to do the arc sine of that. So it goes second, and then I hit the sine button, and that brings up arc sine. And now here, just go second, and then the negative button is answer. If you look really carefully, it says answer. So that'll pop in the last thing in the readout, which was up there. So you don't have to type it in again. And then hit enter. And so 75.34 will round to the nearest degree. So that's about 75 degrees on that triangle. All right. Okay, let's get 7.6 limitations of the law of sines. And so with that, you got to be careful with law of sines. Law of cosines works no matter what. Law of cosines, you'll never ever encounter any problems. Law of sines, it is possible, because I don't know if you remember anything, if you had geometry, we had triangle congruencies like angle, side, angle, ASA. That means if you have an angle, a side, and then an angle, and another one that are the same, then the two triangles have to be the same. But there wasn't one for an angle and a side and a side. And when I was teaching younger audience, I would say, see, because that makes a swear word, and we don't want swear words in geometry. In fact, that wasn't the deal. The deal is you can actually get two different triangles when you have two sides and then an angle. So if it goes side, side, angle, you could end up with two distinct triangles, one obtuse and one acute. And that can happen in certain scenarios with the law of sines. Now, we're not really going to investigate that very much. And so I just wanted to let you know about that before we go on to the law of cosines, that if you get the smallest angle, if you end up with the smallest angle that you calculated, but it's across from the largest side, then that happened. It's the ambiguous case where it's actually the complement of that angle. It isn't the tiny angle that you found, or vice versa. So that's called the ambiguous case, and we're not really going to go over that. I mean, I kind of have 39 to look at it, but they've already done that. So angle, side, angle to solve SV. We would set it up like that. Some solutions involving the law of sines are more complex than those in the last frame. Examples are given. So like number 40, if you go to set that up, you end up with numbers. What are we doing here? Limitations. I thought they gave one with an ambiguous case. So the three sides. So if they give you three sides, you can't use the law of sines. I don't think they're really talking about the ambiguous case, but that is a thing. So law of cosines is the next video that we'll do.